Welcome to our channel. In the last session, we discussed insertion operation in double linked list. Now, in this session, we are going to discuss about deletion operation in the double linked list. Here, we are doing deletion in three different ways. One is we are deleting a node at the beginning of the linked list. Another one is delete a node at the end of the linked list. And another is delete a node at any given position. These are the three possible ways of deletion. Now, first we are moving into delete a node at the beginning of the linked list. What is the first step? Whether it is at the beginning or at the end or any position, the first condition is if the list is empty, means it is not possible to delete. How can you check a list is empty? Remember, we always use head node is the first node in the linked list. Always head is the node which points the first node in the linked list. So if head is equal to null, means head does not consist of any node. Obviously, the list is empty. It is not possible to delete. Clear? This is case 1. What is the second case? Assume you have only one element is available. First case is 0 element and only one element is available. Now, in that case, simply delete the node. Simply delete the node. What is the condition for checking a single node? If this is the head node, head is available and the next to field is equal to null. Understand the point? Head points to the first node and the next to field is equal to null means this is the last node also. That means if head dot next is equal to null means only one node is available. Then what you are doing? Simply print the data and then delete head and then assign null to head means automatically you are deleting. Now what is the remaining case? Either 0 element or 1 element, or if you have more than 1 element. This is the case. Got it? This is head node. Now, what is your aim? You need to delete this node. Before deletion, always print the data. Right, the data is printed. The next step onwards, this node becomes the head node. Actually, what is this node? This is the next node of head. From now onward, this node becomes head. Then assign head is equal to head dot next. Now, what is the meaning of here? Whatever the next to node of head, now that is assigned to head. Whenever this statement is executed, from now onwards, this is the head node. And remember one thing, always the starting node previous value is null. So you need to make this value null. What is this field? Previous. So head dot previous is equal to null. Observe the order is also very important. First, you need to transition the head and then make the previous into null. Okay. This is deleting a node at the beginning of the linked list. Now, to do deletion operation, first you need to do insertion operation. Now, coming to the program that we discussed in the last session. So, here we are creating one node with three parameters, data next to previous. Here I am doing insert begin, insert end, and insert to position operations. Clear? Now, move to deletion. Public void delete begin of. Suppose I will write like this. Delete begin of. I am deleting a node at the beginning of the linked list. What is the first condition? If head is equal to null means there is no element in the list. Simply you are printing some statement. System dot out dot println. The list is empty means it is not possible to delete. It is not possible to delete. Yes. If means if only one node is existed, head dot next is equal to null means only one node is existed. In that situation, what you are doing? Simply print the data at the head node. Deleted is, I am writing some message plus head dot data. I am printing the data. After that, make sure head is equal to null, means the head node is deleted successfully. Clear? Now, coming to the last case, else. What is mean by else? More than one node is existed. In this situation, what you are doing? Simply print the data at the head. Print the data at the head position. Now, head moves to head is equal to head dot next. Head moves to the next position, and the previous value must and should be null. Why? For the first node, previous value is equal to null. This is the way to return delete a node at the beginning of the list in a double linked list. Save. Now, move to the second scenario. What is that one? Delete a node at the end of the list. Here also the first case is same. If zero element head is equal to null, means simply delete the node, or only one element head dot next is equal to null, means simply print the data and then delete the node. Else means more than one node is existed. Now observe, this is okay. The first node is head. What is your aim? You need to delete this node. That means here you can apply in terms of single linked list or double linked list. Now I will explain it in two ways. First, I am taking one temporary variable. Assume the temporary variable initially points to head. So temp is equal to head. Temp is equal to head. Okay. Now my aim is reach the end of the list. My aim is to reach the end of the list. How do you reach the end of the list? While temp not equal to null. Sorry, while temp dot next not equal to null. What is the meaning? Initially, temp is equal to head. Is temp dot next not equal to null? No. One element is existed. If the one element is existed, then I am doing temp is equal to temp dot next. Now observe. What is the meaning of this one? Always the last node next to field is null. Initially, this is temp. Now temp dot next not equal to null. The condition is true. Now temp is equal to temp dot next. Now this is temp. In the next iteration, this temp dot next not equal to null. So temp is equal to temp dot next. In the next iteration, this is temp. In the next iteration, this is temp. In the next iteration, temp dot next is equal to null. The condition fail. That means we are reached the last node. Clear? The last node is reached. Now, what you need to do? Print the data. Print the data. Temp dot data is printed, and then generally what you are doing, temp is equal to null, right? I am printing the data. Whenever you assign it temp is equal to null, this node is deleted successfully. But what is the problem here? The problem is after deleting the node, this is the last node. What is the next field in the last node? Null. But that is not available. You must and should place a null before deleting this temp. Now, how do you make this null? It's a very simple. What is the position of this node? Temp dot previous. Yes or no? Now, this is the temp node. Their previous is this node. Dot. So, temp dot previous means this entire node. This entire node dot next means this value is equal to null. Then here the value becomes null. Here, this is the advantage of double linked list. This is the advantage of double linked list. Suppose if you are not interested to do, you can use like single linked list also. How? Create one more pointer, one more temporary variable. Initially, the value is equal to null. Inside the loop, I am assigning the statement. What is the meaning? Before temp moves to the next position, I am storing the previous address. You got it? Initially, temp is head. Temp dot next not equal to null. PTR is equal to temp, and then temp is equal to temp dot next. You got the point? Before moving the temp to the next node, I am storing the previous address. Why? By the end, temp is this node, this is PTR. Simply print temp.data, and instead of writing this complication, directly you are writing ptr.next is equal to null. But here, what is the problem? An additional node, wastage of memory. That is the problem. You got my point? That is the problem. That is the reason in double linked list. In double linked list, you can use this one directly. Or else, if you all use, you can use. That's not a problem. Now, delete at end. First condition is same. Second condition is same. Only the thing is else case. In the else case, what you are doing? Node, some temp is equal to head. The first node is assumed as the temp. My aim is reach the end while temp dot next not equal to null. Temp dot next not equal to null. In that situation, what you are doing? Temp is equal to temp dot next. I am reaching the end of the list. Once you reach the end of the list, now simply print the data. Print the data. After printing the data, you make sure that temp dot previous means the previous node, their next field is equal to null. By that means the previous node of the deleted node is marked as the last node. Marked as last node, and then temp is equal to null. And then temp is equal to null. This is the way to do deletion operation at the end of the linked list. Now, move to the third case scenario. What is that one? Delete a node at the specified position. So they are given some position. You need to delete according to the position. Anyway, the first case is if head is equal to null means whatever the position you given head is equal to null means the list is empty. It is not possible to delete. Otherwise, suppose if they given position is equal to 0 means we are deleting a node at the beginning of the linked list. Simply, you are calling the method delete beginning. Automatically deletes the node at the beginning of the linked list. Yes, this is the case. Means, what is the case? They given any random position. Within that position, you need to delete. For example, this is the list I have. Consider one double linked list. The first node is head. The indexes are 0, 1, 2, 3, 4. Suppose if the position is equal to sum 2, whatever it is, the position is equal to sum 2. Now, what is your aim? If you want to delete this node, reach up to this one. Yes or no? If you want to delete this node, you have to reach up to this position. For that, what I am writing? Simply temp is equal to head. I return one for loop for I is equal to 0, some I less than position, I plus plus. Temp is equal to temp dot next. Temp is equal to temp dot next. Like this, I am moving. Initially, this is the temp. What is the position I given? 2. 0 less than 2. Condition is true. Temp is equal to temp dot next. Now this is a temp. Suppose next to I value 1. 1 less than 2. Suppose this is a temp. Now I am at this position. This is the node that we want to delete. If you want, along with this position, you can, if you want, you can store this position also like this. PTR is equal to temp. You got the point? Here you can do in two ways. Directly with one node, that is one variable, or else if you want, you can use multiple. Whatever you want, you can do. That is not a problem. Suppose for simplicity, I am taking two variables like this. Okay, right now the deleted node is pointed by temp. The previous node is pointed by PTR. What is the logic? What is the logic? After deletion, you need to make the connections like this. Yes or no? The connections are this next field consists of this next field, meaning is ptr dot next. This is the ptr dot next is equal to temp dot next. Yes, what happened? In the next field, whatever this available, this is copied into here. Now, temp dot next. Temp dot next. What is the temp dot next? This one. Dot previous. Temp is this one. Dot next means this entire node. Dot previous is equal to directly PTR. My program is completed. My two links are formed successfully. Suppose if you are not using PTR means then that is not a problem. How do you make the connection? This link. How do you get that link? Temp dot previous means this node dot next. In the next, you are given temp dot next. You got it? Temp dot previous means this node. In that node, the next field is equal to temp dot next. Instead of PTR, I am calling like this. After that, temp dot next dot previous is equal to temp dot previous. Everything is fine. One more case is there. Suppose I given a position is equal to 6. Is that position is available? Not available. That means each and every time while incrementing the temp value, I am checking if at any point if temp is equal to null, simply display one message break, comes out of the loop. You got the point? Comes out of the loop. Now you are coming out of the loop because of two cases. What are the cases? The first case is if the position is available, then fine, it is possible to delete. Second case is whenever the position is not available, it is not possible to delete. For that purpose, you are using one flag variable. Inside the if condition, I am updating the flag. If flag is equal to 0 means if is executed. If is executed means the position is not available. If is not executed means because of this condition only we are coming out of the loop, then deletion is possible. You got the logic? Now anyway, I will do public void delete position of into some position. Okay. Within this position, what is the first step? The first I am declaring some variable temp num comma ptr. I am declaring two variables. Anyway, the first thing is if head is equal to null means head is equal to null means simply the list is empty. Yes, system dot out dot println list is empty. Whenever the list is empty, you no need to do anything. Simply you can use a return also. An empty return is possible. Without return type also, it is possible to write empty return. No need to check the remaining cases also. Anyway, else. Condition executed means automatically list is empty, message is printed. Else means head is not equal to null means at least one element is available. Now within this check the different cases. If position is equal to 0, if position is equal to 0, what you are doing? Simply call delete begin method. Why? Position 0 means we are deleting the node at the beginning of the linked list. At the beginning of the linked list. Yes. Yes. Means position is greater than 0. Now int some flag is equal to 1. What is the purpose of the flag? Whether the position is available or not available. For checking purpose, I am using flag. Initially, temp. The first node is termed as a temp node. And now I am moving to the position. Int I is equal to 0. I less than position I plus plus. Now, within this loop, what I am doing? Within this loop, first I used one PTR. That means before temp moves to the next position, I am storing the address of PTR. Remember, even though you are not interested, simply ignore the PTR. So you can use the temp dot previous. That is also fine. Temp is equal to temp dot next. Here the condition. Whenever temp moves to the next position, you need to check if temp is equal to null, What is the meaning? If temp is equal to null in the sense, the position is not available. The position is not available. Position not found. Whenever the position is not found, what you need to do? Update the flag variable and no need to repeat the entire loop. Simply break coming out of the loop. If is completed, for is completed. Now I am outside of the loop. Whenever the position is available, I am outside of the loop. If the position is not at all available, I am outside of the loop. If flag is equal to 1 means the if case is not executed means my position is available. If the position is available, then what you are doing? Write down the logic. ptr dot next is equal to temp dot next. Temp dot next. After that, temp dot next dot previous is equal to ptr. I am establishing the two connections followed by print the data. So I am printing the data followed by temp is equal to null. Close the if. This is the way to delete a node at the position also. Now execute. Before executing, call delete begin of ob.display. Delete position of some one. I given some position 1 ob.display. Delete end of ob.display. Actually, display is not at all required. Why? After deletion, I am printing the value. So to show the remaining elements, I used the display method. Go to the command prompt. Execute. So system.out.println position not found. Simple one error. Delete end. This is some error. Okay, we will move to that error. Here. Delete begin. System.out.println and which position? Cannot find symbol. Println. The spelling is correct. Println. At one way we are using wrong spelling. Here. Println. Now delbign. Fine. Save and execute one more time. Now what are the errors? Variable ptr might not have been initialized. Delete position. Okay. See the delpos. Delete position. Here node temp is equal to null. Node ptr is equal to null. Now one more time. Now error cannot find the symbol delbegin and delpos cannot find symbol delend. Okay, just to cannot find the symbols del begin, end, and this one. Now observe what is the problem here. The object is ob del begin. Here this is ob dot. Forgot to call by using object. Clear? Ob dot. Save. Now fine. Now observe of this is my list 30, 20, 10, 400, 200. Delete at beginning. 30 is deleted. After that, these are the elements. Now what we called delete at position number 1. At position number 1, we have the element 10. So 10 is deleted. And what is the deleted element in this? Delete at end. 200 is deleted. Now we observe this is the concept of deleting a node in different possible ways in the double linked list. That is the end of double linked list insertions and deletion operations. Thank you.